It's undeniable that 3D printing is taking a skyrocket in terms of what it's being used for globally right now. And it was always a bit of a science fiction dream of ours that you could teleport medical equipment to anywhere on Earth. The hardest part was convincing people of what this could do, because you don't think it's going to be anywhere near utility phase right now. PolyUnity was birthed out of an original idea that me and my two co-founders had while in medical school. We each bought $300 3D printers that had basic capabilities. We didn't know what they could do, started learning a little bit about the hardware, the software, what we could do with them, and before you know it, we had a little lab rolling at the med school here. Just being in medicine, some of the more applicable things that we started doing were playing with simulation medicine, because it was low-hanging fruit that we could print. There was no patient confidentiality issues, and it could demonstrate that there was usefulness of 3D printing, especially in medicine. And that was about 6 years ago now. You know, most times, the first time any medical student or resident does a procedure, it's on a person. Doing training simulations that are more true to real life and having a little stepping stone in between, it gives you a little more confidence. It allows you to have the muscle memory down to perform that a little better. So we just wanted to design, create, and print things, and based on a central library of things, just run your own local in-house manufacturing. We grew up in Newfoundland. It's a very distributed, under-resourced place, and healthcare delivery is a bit tricky at times, given weather, geographical isolation, stuff like that. So we set up printers in 6 or 7 rural sites and just got the buzz going about 3D printing and what it could do. A good highlight point is in Carbonear, which is about an hour and a half away. A couple physicians out there really latched on to the idea and really quickly started asking us to develop simulations for them. So this is our tracheotomy simulator. Underneath is the trachea with all the appropriate landmarking that you'd need to identify the critical spot to put the airway in. And a secondary membrane that we applied here that gives you the tactile feedback as you're going through with the scalpel. And then on the inside, the trachea has rings. And when you place the airway, it clicks down the different rings of the trachea to make sure you know you're in the right place. And this model has actually been used for resident training in several schools. The whole idea of this one is just to recognize disease or pathology on the inner ear. So once you put that in there, assemble the whole thing, you can get an otoscope to look in the inner ear, and people could just train to see what the different disease processes are on the inside of the ear, and even practice putting tubes in place, which is a skill that all ENT surgeons have to do. I think you'll see very soon applications are going to be cleared FDA-wise, Health Canada-wise, and more globally on even 3D printing prosthetic parts for surgeries, custom hip replacements, or custom replacements for bones in your face if you have to get them removed from a cancer perspective or something like that. And even more so, customized medical devices, so orthotics for your shoes or knee braces that are built to your anatomy. One of these things is a toy, but 40 or 50 or 60 becomes a tool, and a pretty powerful one, but only when managed appropriately. So when we built this farm a few months ago and had to scale up our production for pandemic relief, we were tasked with making face shields for our area of the province. We were a little naive in thinking that we could put all these printers in one place and it would click our fingers and it would work. Fortunately, we had enough people hired, boots on the ground, that had enough skill sets in 3D printing and design and technician work and mechanics and all this stuff that we very quickly were able to pinpoint all the problems and pain points in managing a farm, patch the holes with pretty simple software packages, and then bring our scalability way up from, I'd say, about 200 face shields on these printers in one day to 2,000 in a day in the span of about a week and a half. We recognize that people will want print farms, even as a node in the manufacturing process. So from design and idea to your large-scale injection molding style manufacturing, you can use a print farm for that intermediate step. I do think there's going to be a big wave of customized medicine, a big wave of customized design in healthcare, but also just in a lot of other industry. And what we hope to do is just make that process more accessible, cheaper, and reasonable to do as a company.